10.4, inscribed angles. So there's a little bit of a difference with an inscribed angle versus a central angle. An inscribed angle starts at the edge of the circle. Now the central angle was started in this center. So the measure of an inscribed angle theorem. So the angle itself, and we're talking here. So the angle, well, let's put some letters in here to be more specific. The angle ABC equals half of arc AC, of arc. Now, that's the formal definition, or the formal, how you find the measure. Here's the trick I give kids. Inside equals half outside. Students seem to remember this a little bit easier than the formal definition, okay? So the inside part of that angle is going to be half of the outside measurement. Outside obviously is outside, inside. So just something to think about here. So example 1, determine the measure of arc QT, and then determine the angle measure of RTS. So I have QT is with that angle there. I am going inside to out. So my inside is 50, which is half of my outside. Therefore, my outside is 100 degrees, aka arc QT is 100 degrees. Now let's switch it up and go the other way. So, looking at this one, we have the outside, which is 48. Half of 48 is 24. That's the inside, which we know is an angle measure. So it's angle RTS, 24 degrees. Inscribed angles of a circle theorem. This is saying if two angles, inscribed angles, have the same arc measure, then the angle measures are going to be the same. Kind of obvious there because they have the same arc measure. Therefore, the angle measures are going to be the same. Straightforward. So if I'm looking at this, determine the measure of EHF. So EGF is 51. Therefore, EHF, which in my situation is red, is going to be 51 as well. Done. Inscribed right triangle theorem. Inscribed right triangle theorem. What this is saying is that you have to have a diameter. So this is a triangle formed with, with the diameter. Okay, so what this is saying, that angle there is going to be a right triangle. So we'll make it more specific there. Right triangle formed with the diameter. Okay, so you can then use your different information from a right triangle in order to figure out your different measures. Inscribed quadrilateral theorem. Let's see. Opposite angles are supplementary, aka they add up to 180. Again, just applying these different theorems. So, example 3, determine the value of the missing angles. Right away, I have a right triangle because it's formed with that diameter. So x equals 90. Y is going to be 180 minus 90 minus 40, which is 50. And example 4, determine the value of the missing angles. Opposite angles are supplementary. So x plus 82 equals that 180, subtract it off, and I get 98 for x. And with the y, I have y plus 68 equals that measure of 180. So y is there going to equal 112. So just using that information, like I said, the inscribed angles, a lot of people will get it confused with the central angle and vice versa. So just something to note, make sure you understand where those angles, where they're formed, if it's formed from the center or if it's formed from the edge. So there's 10-4 in a nutshell.